Okay, today I decided to make some break-in changes to simplify the code, architecture, the designs and stuff. What really happened is, since this was very old code and I was trying to resurrect it, I was trying to run certain graphs, certain old design types, and check out how they work. And I found out they stopped working. There was some issue in one or two of them, and was while debugging the code. And I don't come back to this code every day, every maybe 6 months, or sometimes when it's like a playground for me. It's like experiments to learn few things. So whenever I was coming back to this, I found out like the code was very complicated, and earlier code allowed us to do a lot of things. It allowed us to within a for loop, break the for loop to make a jump. We used to call them hyper jumps. It used to allow to make background jumps. It used to allow to call virtually without a hyper jump. A hyper jump would be if you have a for loop and within a for loop. So with the innermost for loop, you can jump out to the outer for loop, call it anywhere. Then another one, a hyper jump, another type would be where you could jump even from the loops and loops to somewhere really outside, even outside the nested loops. So the code was good, it was really cool feature and everything, but I found out I really never used that feature. And there are two reasons. Is in the UI it became so complicated to understand, to trace it, and similarly in the background to code to maintain and run it was very complicated. So I decided to simplify that. We have a lot of mappers, so this will not break any of the new mappers, any of the new activities, but any of the old ones, sorry. But the new ones will follow to the new paradigm that I am planning from today. So all the old ones should work because they use the old compilers and the old way of doing things, but any new stuff should be used building the new paradigm that we are setting today. Second thing, we are also setting certain guidelines how to do things. So when we are defining a graph, right, earlier the idea was you could define it as a int or a string, and then depending on what is the value type defined in the back, it would translate it. Now we have made it explicit. So if it is string, it should be in the quotes. If it is integer, it should be like defined as integer without string, as you would do in any programming languages, right? We recommend using double quotes, not a single quotes. And there is a programming paradigm designed for how you should design your component or the code in the component that takes care of it, right? So if you define this, and there is certain way to define input and output variable, and that will take care of it. So that will go to the component kind of think of designer manual. Today we are also bringing back one feature that I think was broken. It was there about 7-8 years ago. Basically, like this wire is wiring from the input of one to the input of another, which was broken. We could only wire output. Somewhere that change was broken, so that is fixed now. Other feature that we are bringing back is when designing the outputs, right, we were allowed to give certain values override. That is no more going to be allowed because you cannot have a default output in here, right? This will be basically the name of the variable that will be used. And we are writing a new engine. There were a lot of old engines written. For example, these are different mapper compile type. They have their own 2-3 different engine types depending on what kind of complexity would it. For example, compile mapping would is a simpler engine because it is a data flow graph, right? It's only it's a DAG basically. But for example, compile to code, compile to Java, compile to JavaScript, they have backtracking and they allow to do certain things. So they were using different engine, and these engines are coded basically in the controllers. And then they compile to code even had a much more complex, I think the most complicated, that allows to do hyper jump, virtual jumps, come back from there, jumps too. So but the code is so complicated and I'm not maintaining it daily, so it's super hard for me to go through the code and read it and maintain it and fix bugs. And this is just a fun activity for me. I'm serious about it, but it's like a fun playground and experiment for me. So I'm not doing much. If somebody requires, we will go and modify those ones too. But right now, this we will leave to them to where they are. So old graphs will run with the old compilers. The new graphs, the new designs should follow the new paradigm. And the way to design the new paradigm is very simple. If you are defining an input variable, right, we recommend defining it like this. Okay, so try to take the input parameters. So the input parameters are defined in these ellipses, and these are defined in the angle brackets. Output parameters are defined in angle brackets. So input parameters you define as what is the neighbor of input parameter variable, and you define what is the default value. Similarly, for the output variable, you define it while defining as the variable. So the syntax would be variable type, this kind of definition, and whatever the default value you want. This default value should match with this value that you define in there. Similarly, in definition of the input parameter, you define it what is the input parameter is, and value can be in quote if it is string, if it takes strings, if not. A best way to define this is you can define like this. So if it is somebody specifies integer in UI, you can convert this syntax will convert into there. So we recommend every component you are designing or component designers should use this syntax, right? And this way it's safe. If somebody puts an integer or a string, it will work fine. If somebody feels this component is always going to take a string, everybody will know it's a string, so you want to do optimized. So you can basically do some optimization here and not have to do the casting, and can just, or casting or appending, you can just take the string as is. So, but this is what is preferred way of designing. And when you are designing the output variables, and let's say output variables need a default value too. So the right way of designing now is, earlier we allowed to define the output variable default values in the UI. That made the engine very complicated. Now we simplified it. If you need an output value, that is should be default. First define input value relative to it. Input value will be editable, and the output value will use input value. For example, here is the output value 1, which is defined as string, and now it's taking value of input value in 1, which is here, right? So you will define input section, you will define the output section, output, and what you do with variables here, and then they will be output. So this is the now going forward syntax for it, and this will work fine. Here this is written a more optimized there, which we are expecting always string, because this is a very simple message so it's very clear message has to be string. Here we don't know what it is, right? So depending on what kind of variable you have, and in this component it is as out, it's very simple, it's a message, so you just always expect string. You can make it optimize it by doing it this. There is a casting in there that is required. The reason casting is required is when we are doing context wiring mapping in the back engine. The engine earlier used to use static object. So every time there is a object that we needed, that would create that object and pass through. Now what we have done is, for making it simpler to debug and check, we have defined a context called map, and that map holds the context of the whole running execution of this graph. So even though it is compiled in the code, those variables are not directly used, they are looked up from a map and inserted. So every wiring that you see here has a penalty of a map lookup, which is O1, very small, but there is a penalty, right? Earlier this penalty was not there, so it was run really super there. In future we are planning to modify the engine, so you can configure the engine and say I want a static wiring, not like a map lookup, so it will be more optimized code. But right now there will be some nanosecond penalty to look up from a graph. But the code, when it compiles, it only builds map of objects that are wired. For example, here this is wiring is there, so it will only take this and these two values into map, and up to here it will take this, right? And what we are thinking is, in future we will have a map dissector. So what it will do is it will look at the values, so the values that are not used, it will keep garbage collecting them. But right now we will leave as is. We want to focus on the feature, because this is already optimized. The only thing difference between this and hand coding is this wiring as adding a map lookup penalty, right? And that is done for debugging at every stage, which is really a good idea. So going back into the engine, there is another enhancement that we have made. Earlier automation graphs required you to explicitly tell which connections are the order of execution of the graph. Now if there is a wiring, you don't have to connect, so there is no connection between this module and this module, because we know from this mapping this comes before this. So the topologically sorting is done after building this interrelationship between the modules. You can explicitly go and specify too if you want to. So you can specify explicit relationship between these two modules, but it's generally not needed, right? And if you define an interrelationship like this, we are not validating right now that this is a break-in change, because you are asking after this execute this, which is fine. In this case it will topologically sort fine, but if in this case the wiring would have been reverse, right, then there would have been a problem, right now it is fine. It depends on this and this depends on this, so it automatically knows I have to execute this one first and then I have to go to this one, right? So this is basically just a dependency, right? So the dependency will be from here to this dependency, so this basically will compile into this. So it will look, compiler will compile into this graph here, right? So in this case it will already knows that this has to be executed first, this has to be executed first, so this is fine. But there could be a dependency, where it depends on these two and somebody could not have this dependency. So now the question comes, which one to execute first, right? So in that case, since the dependency will not be there, right? Let's say I select this one. Now I say there is no dependency, which one to execute first? Then the compiler can choose either to execute this and this, because there is no dependency, right? So yeah, these are all the enhancements done in the engine to simplify it, and going forward that is what we're going to be used everywhere. And other feature that is there is the cycles detector. Earlier we have built our own cycles detector to detect the cycle for the for, if, and or. Now we are going to use the standard cycles detector to detect the cycles. Right now we don't support in this new design nested, but the nested support will come soon. So n level of nesting will be supported. Right now only one level of nesting is supported. So I can have a for graph here. Let's say I add another, let's say another graph here, another this here, I connect it here, and then if I add a dependency of from here to here, right, we already know there is a for relationship. When you are defining a for, we recommend you explicitly do the wiring, right? So now it is clear that this is calling this is calling this, so this is a for loop. So this will be this level, one level of nesting is there, but within this if there is another nesting, we don't support it right now. We are going to add that support in future, but not right now. So that is there in the list of our there. So two things that we are going to do is, one is whatever is in the map, dissect it and remove the and garbage collect the unused, and second thing, support the L level of nesting. That's what we are going to do. But yeah, this design will simplify it. It will also allow me to be able to maintain the code, and it will be very clear to the designers who are designing what they are designing, and the users of components will be very clear what they are using. Thanks.